Anyway, thanks for having me. This is a very simplified and basic discussion about piles in permafrost. Probably should have just been foundations in permafrost because we talked a lot about shallow at grade foundations, some pile foundations and so on. But we're just going to talk primarily about pile foundations in permafrost. So there's a whole variety of foundations. We've talked about a few. And again, today we'll be talking just primarily about the slurry piles or the driven piles in permafrost. There's a whole variety of other foundation systems that get used in the permafrost environment. But first, before we get into the piles, I want to talk a little bit about something that you're a little more familiar with, shallow foundations in permafrost, or shallow foundations just in thawed ground. Many of us live in thawed ground communities, and the way that we use our foundations is we let heat loss come out of the house, and it keeps the ground thawed, and it keeps it so that our house doesn't jack around or move, and we balance the energy from the heat inside the house and the cold outside the house to keep us in thawed ground, right? And that's while we have a lot of people from communities in permafrost here today, this is kind of a more traditional, if you will, outside of the permafrost realm, what we do. And so the problem is in permafrost regions, we have this permafrost, and when you heat it up, it turns into soup. It turns into goo. You can imagine pushing on this permafrost on the sample on the left. You can push on it, and it's pretty firm. It's nice to build a foundation on. But you can also imagine on the right pushing your finger into that goo in that jar, and it probably isn't that stable, right? So because of the heat coming out of the house, we like to elevate the foundations, and you can see this around Utqiagvik really readily. I was in the bus with a few people looking at the foundations as we were driving into town, and people are observing. We've got these square piles, we got these round piles, we got a few different flavors, but what you see primarily is these houses that are off of the ground, right? And that's to decouple the house from or decouple the structure from the ground below it, and maintain that heat, or keep the heat from going into the ground and thawing the permafrost. Another thing that you don't see a lot of is concrete around here. How many concrete foundations have you seen in Utqiagvik? And not too many, right? There are some there, but cost of concrete, say in Anchorage, where I'm from, is about $150 a cubic yard. Okay. And then if you were to do it in rural Alaska, it's about $1,500 a cubic yard. So tenfold increase in cost. It's pretty inefficient to do that. There's a lot of reasons why. Shipping batch plants and all the materials that you have to bring into rural communities is just not that efficient. And so as with the thermal protection and then the cost of other materials, we see a lot of pile foundations. So they're wooden piles, steel piles, you name it. Yeah, we don't see a lot of concrete around rural Alaska, and that's primarily a cost factor and efficiency of getting materials here. So a lot of you that have worked in the permafrost regions, we kind of understand this, but I think it's worth taking a step back and making sure we're all on the same page with respect to what you're seeing out there. So piles in permafrost foundations, we have a number of different pile types. Driven piles, so a lot of people are familiar with the driven piles. You use a pile hammer and you beat that pile down into the ground. The slurry piles are drilled holes that you'll set the pile in and then slurry back and let it freeze back. And then we also have a number of other types of sub pile types, helical piles that can be screwed into the ground, and a number of others. Oftentimes with driven piles, they can be pretty difficult to drill, and so you'll see a lot of these more slurry type piles where you'll drill the hole first, and then you'll install the pile and let it freeze back. And so here's a picture of a pile program I was working on in Stubbins. And the permafrost isn't actually that stiff, or if you will, or frozen in Stebbins. It's I don't know, -2 degrees Celsius, and we had a bunch of problems driving piles, right? And so even that hard of ground, and we had some difficulties. There's a great UAF. What is it? The pile that crumpled up like an accordion, is sitting there in the engineering department. If you're ever at the UAF facilities, take a look at that pile. Great example of crumpled piles. So this is a personal example of something that I've had to deal with driving piles in permafrost. So anyway, you got several different types of piles. And so I want to talk a little bit about how piles work. All right, and just so we're all kind of on the same page here. They essentially have what's called an ad-freeze strength. And that's the bond between the pile and the soil. I don't know if any of you have licked a flagpole in the winter. Right, that's ad-freeze, ad-freeze strength of your tongue between your tongue and the pile or the flagpole. That's the same thing that's going on within the soil as you let it freeze back and grab onto that pile. You also have a creep movement. So there's that ad-freeze strength, that's that bond between the pile and the soil. But then there's also what's actually probably more important in ice-rich permafrost, like Point Lay and other communities, where you have this more viscoelastic response or behavior, where you have creep movement over time. You have this load that's applied over a period of time, and things just kind of sink into the ground. And so that's that creep movement. That's oftentimes, especially with heavy loaded structures, what really drives the design, if you will, for how much movement you can allow. So there's a number of, let's see if this no, a little laser. So if you look at the figure on the right, you've got thawed soil. You've got this potentially an active layer that's freezing and thawing, and then you've got the permafrost down below it. And so with these piles in permafrost, essentially all of the load is primarily captured or taken by the soil that's in that permafrost layer. So if that permafrost layer continues to degrade and drop down, you have less and less pile, as we were talking about with Billy's presentation, about you have less pile that's grabbed by that permafrost, or less pile that's stuck like your tongue on the flagpole. And so that's kind of an important piece of design, is understanding how much of that pile you need, how much of that length you need to go into the frozen soil that's frozen for a good long time. Engineering is a bit tricky, because we have to forecast, is it a 50-year design life? Is it how long do we want this thing to last? And then what does it look like? What do the ground conditions look like for getting that to perform for that length of time? So if you look at there's a number of different kind of loading conditions. You can have the pile being pulled out of the ground. It could jack out of the ground due to the freezing of the active layer. And so there's with lightly loaded structures like flagpoles, you get potentially some jacking out of the ground just from that grab of the active layer, jacking that pile out of the ground. You have to have it deep enough in the permafrost to resist that as well. So there's a whole, this is I tried to kind of simplify this presentation quite a bit, because there's, you go to school for years to kind of work through these things and deal with these issues. And so kind of wrapping it into a, 12-minute presentation is a bit tricky. But so if there's anything that you're really interested in, we can talk, because this is a fun topic. But essentially, the depth of the pile is decided by how or what kind of material you have, and then what kind of temperatures you have. So temperature is very critical in pile or permafrost design of piles, as well as the type of material. So if you have piles in ice, they're going to behave much differently than piles in frozen gravel. So those are a couple different pieces. And then warm versus cold permafrost, again, very different responses. So the warmer the permafrost, the deeper the pile. The colder the permafrost, the shallower the pile, as long as you've got, and it will depend on more of the ice and the creep movement. So this is something I stole from Beeshazen, which I think he stole from Vladimir a bit and did some analysis on. A nice little presentation about what 1976, this is 1976 in the oil patch versus 2022 in the oil patch, and then 2050 prediction of probably a linear extrapolation of temperature at depth in the oil patch. And so you can see here that we've got freezing. The active layer is not changing that much. Top of that curve is not changing that much, but you can actually see there's a fairly significant shift of temperatures. These are permafrost temperatures in the oil patch, and then also from 1976 to 2022. But then the guess of what it's going to look like in 2050, because again we have to look forward as engineers and try to design something stable for a long time. And just running rough calculations, the depth of a pile in 1976 with the same load versus 2022 versus 2050 is 18 feet, 24 feet, and all of a sudden we got 46 feet in 2050, based on the projection of what the climate may produce and the permafrost may want. Now, if you think about it, there's a lot of, how many structures on the North Slope were built in the 70s and 80s? A lot of them, right? Quite a few of them. And so when your engineer is doing the number crunching, they say, oh, an 18-foot pile, maybe we'll throw 20 feet on there just to make sure everything's good. And there you are, right? And so 1976 to 2022, all of a sudden you really don't have enough pile anymore, right? To carry the loads that you're hoping to carry. And now you're eating into what we call that factor of safety against failure. So now all of a sudden we need a 24-foot pile, but 3 minutes. All right, we're doing this great. We're almost there. You're almost done listening to the engineer. But in 2050, we're down to 46 feet. Now, how many pile foundations have you seen up on the North Slope here that have piles down to 40, 50 feet? One. All right, we got one. All right, and so right there, it's kind of a somewhat eyebrow raising because we can see that we have potentially some future issues that we may have to deal with. I'm just going to touch quickly on thermal siphons. Thermal siphons are in this case, a passive system that cools the ground by drawing the heat out of the ground. And it's used to drop that temperature of that pile and the area around it to get you some extra capacity so that you don't have to have as deep a pile. They call them heat probes in the or heat pipes in the Alyeska pipeline. We're going to be riding down the haul road, and so you're going to see a lot of these sticking up out of the ground. This other one is the fins haven't been put on the top for this wind tower foundation, but those are kind of what they look like. They put a thermal siphon on each pile to try to cool those things down. There's a whole bunch of applications of thermal siphons as well, so this doesn't do that justice. But so that's about it with respect to piles and permafrost. It's a pretty complex topic, but wanted to keep it somewhat simple and just highlight that temperature dependence and the things that we're starting to stay up at night thinking about, kind of worrying about as we see Vladimir plotting these temperatures over time and how those are changing. So anyway, there you go. Thanks.